Alright, in this course, we're going to be going over the quickest and dirtiest way you can rig up a character. I'll be doing a much more professional and in-depth rig of a character in the next video. I'll be doing that today at some point, so hopefully in the next few hours after this video gets uploaded. Right now, a lot of the time, you'll be working on something and you'll have some small character part or some small thing you need moved, and you don't really care about spending the hours and hours and hours to professionally rig something. So you just want kind of a quick and dirty rig. For this example, I'm going to hit tab and I'm going to drop down a test geometry Tommy. And it's a good idea just to make sure you're rigging on the base skin. So I'm going to go ahead, I'm going to turn off his clothing. And we're going to drop a skeleton. I don't like that. It's skin texture looking at me, so I'm gonna turn that off. I'll just work with the mesh. And a skeleton's node is going to be if you hit enter to make sure you're in the state view. It's going to be our main way of creating joints and bones. We can create bones and joints in other ways in KineFX, like you can use curves. Curves are edges to create your bones. But that's something we'll get into later. And honestly, the skeleton SOP is usually the one you want to be using to create your bones. Okay, so the way it works is we can just start dropping down and clicking in the viewport, and we'll instantly get these joints. Now, if we want to, you'll notice it keeps creating the bones in kind of a chain, one after another. And if you want to stop this chain, so we don't want this next bone we drop to be connected to this endpoint, we'll go ahead and we'll hit Control and middle mouse button click. And now we can start a new chain anywhere else we want. Control middle mouse button click again. Or we can actually start a chain branching off of any of these joints. So if I click on this joint, you'll see this is now branching off of this guy. Okay, so I'm going to delete this just so we can start fresh. And I'll create a skeleton SOP. And to work with this the way we want to, I'm going to go ahead and I'm going to merge these two together so we can see the test geometry and work with the skeleton SOP at the same time. So a quick hotkey for doing this is if you have two things selected. So I have my skeleton and my Tommy selected. I'll go ahead and I'll click on the outputs for this, and then I'll just hold Alt and click, and it's going to automatically drop down a merge SOP. And so what we can do from here is we can start looking at some of these skeleton create joint placement modes. So by default, the mode is set to view based, which for quick and dirty rigs, you actually probably want to be using this. Normal based is going to use the normals of the skin to kind of interpolate and try and find the center point where it's going to drop the joint. Freehand is going to put it anywhere in free space, which is typically what you want for something like if I went into the front view and I only wanted the joints to be created, you'll see exactly on this plane, then freehand is what you want to use for that. Otherwise, if you do it in open space, freehand is going to be weird because it's going to try and guess where you're dropping these points. So just undo all of that. Escape, enter to get back into this viewport. So I'll show you what view-based does. Well, actually, I'll show you surface real quick. It's going to put the joints on the surface of whatever you're clicking on, and it has to be viewable in the viewport. So go ahead and delete this and drop a new skeleton. And I'll show you the view base, which is typically what we want to use for a very quick and dirty rig. So if I highlight the merge, and then I have to have the skeleton selected with the merge still highlighted for this to work. I actually think I'm not even sure if I need the merge. Yeah, I actually don't need the merge here, just as long as whatever geometry you have is highlighted and the skeleton is the one that you selected. Okay, so we're going to jump into view based real quick, which is going to take wherever you click, and then it's going to try and find the first intersection and then the last intersection with the mesh, and it's going to try and put the joint in between the two. So for an example, I'll just show you real quick. If we drop on the shoulder, the elbow, and the hand, we'll notice we get this bone chain that is in the center of our mesh, or at least Houdini's best guess of where the center is. So it's not always perfect. And for a professional rig, we would probably use other means. And I'll get into that in a little, but this will work fine. Again, I'm not trying to discourage you from using this technique because a lot of the time a professional rig is way overkill for a lot of things that a lot of people do. So it makes no sense to rig like that for everything when all you need is something quick and dirty. So we're going to jump back, hit escape, and enter again to make sure I'm in the correct state. And we're going to start rigging this guy with the spine. So you don't have to name these, but I think it's nice and it definitely helps for when you're mirroring stuff. But I'm going to drop a joint where the hip is. That's where we want our first joint to be. And then I'm going to drop the second joint somewhere around the spine end. And then we probably want to drop down where we want the head joint to be. And then from there, probably a jaw joint. And then control middle mouse button click, and let's make a head joint. All right, we'll fix this up a little bit here in a second. We probably don't really want to do a ton with the jaws and the head and all that stuff, because this is just a quick and dirty rig. So we want some more subdivisions on this this spine. We want to we don't want just one curve, and so instead of making a spine like that and making a bunch of them, we want to jump into the modify view after we've created this spine joint, and then right click, and we want to press split selected links, and that's going to split it in half. And if we want more, then we'll go ahead and, with all of them still selected, we'll hit split selected links again, and now we have 4 of these spine links, and they're all aligned with each other, so it's nice and easy to manipulate. All right, so let's jump back into the create mode. Let's go ahead and do the, let's see, that's his left, and it's the left side of the character. So let's do a upper leg, middle leg, ankle joint, and then the toe. And let's control middle mouse button click, and that looks fine. So now we're going to go from the top of the spine, and we'll go ahead and create a shoulder joint, an elbow joint, and a hand joint. That looks good. And now the fingers can be a little tricky, but we'll go ahead and do those. And I'm going to go ahead and, just because the clipping on this viewport is kind of bothering me, so I'll just dial this in so that it doesn't clip when I get close. That's just a viewport thing. Don't worry about that. But so let's do the thumb, and the thumb is 2 joints like that, and control middle mouse button click. Let's do the index finger. Great. Control middle mouse button click. Do the middle finger. And then we can go into the tweak mode if we want, so we can actually edit some of these, just if it's not perfectly lined up. And tweak mode will allow you to, if you select the on a bone, if you select like on the actual bone itself and not the joint, you can kind of rotate around the joint axis by where you grabbed, which is nice. All right, so that looks fine. And then I actually don't think I need to hop out of tweak mode, but I'll just for the sake of it. All right, so now, whoop, I don't know what I just did there, but keep creating these joints. I'm going to hop out of tweak mode. I think it's doing some weird things. So all right, awesome. So that actually is most of what we need to do right here. All right, now all we need to do from this point is we want to mirror these arm and leg joints across the z-axis, which is why I mentioned that it's important to have this thing centered, just because this makes it easier. So all we'll do from here is we'll drop down a skeleton mirror. And from the get-go, it's going to mirror it over the z-axis. And it's going to mirror everything. So it's actually going to mirror our whole skeleton. We don't want that. We just want the limbs we want mirrored. So we'll go into the group and we'll make sure we select this icon. And we'll go ahead and we'll just select all of the joints that we want to be mirrored. And then we'll hit enter. And now we should have just the joints we want mirrored across, and everything looks great. All right, so I'll show a quick way of, now that we have everything mirrored across, I don't like how the jawbone is aligned, so we can just drop a rig pose and then align it with, if I hop into the front view, I can align it with the rest of kind of the neck bones and everything, just so we don't get any weird stuff going on. So that's fine with me. Again, since nothing is bound yet, it doesn't matter. I know I mentioned that we don't want to be translating these, but since that only really applies when we're deforming a mesh, when we're building this skeleton, we can transform these all we want because nothing is bound yet and we're not deforming anything. So we're just kind of setting up where we want to capture this skeleton. We're setting up the rest position of this skeleton, essentially. All right, so now that we have our skeleton lined up and made how we want, I'm going to go ahead and we're going to start binding this to the skin, which is an easy method, but there's a few knowns involved, and for someone who doesn't know how to do it, it can be a little bit confusing, so I'll run through it real quick. So I'm going to drop a node just for organization purposes and call this skeleton rest. Hold Alt to drag this out and create a new one. I'll call this geometry rest. All right, so now that we have our skeleton rest and our geometry rest, we can start binding this to the skin. So how we want to do that is we'll go ahead and we'll create a, we need a few nodes for this. It's pretty simple, but for someone who doesn't know how to do it, this step can be very annoying because you do need more than just the biharmonic capture for this. So the first thing we're going to need is a bone capture lines, which is going to take our, if we display these points, that's going to take our skeleton rest, and you can see we only have these joints, and it's going to turn it into a resampled curve, essentially. So we can actually increase or decrease this resolution by lowering or raising this max axis fraction. For me, this has never actually affected much at all for our deformations. I might be missing something on this, but for me, the defaults have always worked perfectly, and I've never ran into any issues. So I always just leave this guy at default, and that's the first node. And then the second node we need to drop is, we have two options for this. So there's a tet embed and a tet conform. So let's start with the tet embed. And the first input of the tet embed is going to take the polygon mesh. So it's going to take our geometry rest position. And the second is going to take our bone capture lines. So we will hook it up like so. And this is going to create a tetrahedralization of our, if I turn display points off, you can see we have this rest geometry, and then we have our tetrahedralization of it. I hate that word. And we'll go ahead and you'll notice right off the bat that it's much bigger, or like expanded from our rest geometry, and that's because enlarge input mesh is on by default on this node, which actually causes some problems typically for me, because you'll see here on our fingers we have this kind of cavity gap here, and when we turn this on, we have these overlapping areas, which is actually going to run into some issues where if I highlight this and template this guy, if later on we're trying to deform just this index finger, we could run into some issues where that actually has effect on this guy, and we don't want that. So typically if we're using a tet embed, I turn off enlarge input mesh, and if you want higher resolution on this thing, and this actually does affect your deformations, you can drop down this min triangle scale size. So if I go something like 0.001, you'll notice as soon as it's done calculating, it's going to take a second, we have more resolution around areas where we need it, like under this arm and things, which is great and what we actually want. The lower we go, the more computation time it's going to take. But the one thing we got to remember about this is that it only has to compute once. This isn't something that's going to ever slow down our deformations down the line. This is just a one-time thing that we're going to be using to capture these weights. So 0.001 is fine for me on this. And so then the other option we have is a tet conform, which works in the same way as the tet embed, but it's going to take what geometry we have here, and it's going to create tetrahedralizations directly out of these polygons, as opposed to kind of remeshing it and creating its own tetrahedralization. I usually like the tet conform better than the tet embed, but it really depends on your input mesh. It's not that big of a deal. You won't notice very much at all, but I usually think the tet conform is more accurate and more and faster to compute. The only time I think you wouldn't want to use a tet conform is if you have geometry that's really unevenly divided, like really not clean geometry, where like say everything else here is exactly how we have it now, and then we have like a big polygon right here, like something massive, we would cause some problems. Small differences like how these polygons are smaller than these aren't going to matter at all. And I'll show you what this looks like here. So we'll bring this tet embed over here. I'm going to disable it and hold Y to cut the wires from it so it's not getting in the way of anything. And then we'll plug the first input of our tet conform into the rest geometry and the second input into our bone capture lines, just like we did for the tet embed. And then give it a second to compute. Right now that's computed, you can see we have a I hate this word so much, but we have a tetrahedralization of our mesh geometry. And you can see that looks fine. And I'm going to go ahead and I'm going to use this tet conform for our example. So again, both the tet conform and the tet embed work fine, and I think by default the tet embed is the one Houdini uses, but I sometimes have better luck with the tet conform. So from here we're going to drop down a biharmonic capture, and this is the last step we need to capture our weights. And in this first input on the biharmonic capture, we're going to plug in our rest geometry, and on the second we're going to need to plug in our capture geometry, which is what we just did with this tet conform. And again, Same thing for the TED embed. TED embed, we go into this second input as well. So we'll turn this on, we'll let it compute. All right, so now that it's computed, I'll drop down a null, and I'll call this character rest bound. Okay, and so now we can go ahead and drop a bone deform. Bone deform. We can plug in our geometry to deform is going to be our everything after this bone captured by harmonic, and then our rest points are going to be this rest skeleton that we have up here. And then because we actually don't have any deform points, we're going to again plug in our skeleton rest, and we'll just drop down a rig pose on this third input here. And you should be able to see now, if I start manipulating stuff. Oh, I didn't want to translate anything. You'll see now we have our mesh in a way that we can deform. And right out of the box, rig pose is a good little a way we can deform things. And I'll show you how we can get a little bit more accurate of a deformation. Turn that off. So for starters, on the bone capture by harmonic, we can increase this max iterations and lower the tolerance if we really need to. Something like 3 maybe. And this is going to take longer to compute than before, so I'll hit stop. All right, so now that it's computed, one thing we want to do is we want to store this some way, because we don't, if we're bouncing back and forth between a lot of stuff, every once in a while this bone captured by harmonic will actually recache, and we don't want that. So we can do a few things. The quickest way we can do this is just with the stash node. The one thing I don't like about the stash node is the stash node stores anything you plug into it and stash into it into the hit file itself. So now this is in my KineFX rigging from start .hip file. And the reason I don't like this is if you start stashing too much stuff to your hip file, it starts taking a lot longer to actually save your hip file. So this didn't really impact my file size much at all, but if say I'm working with some huge geometry or something that's like a gigabyte in size, and I stash that, now every time I save my file, it has to save that whole gigabyte file along with it. And eventually you can start running into situations where it might take 30 seconds or so to save your hip file. And that is incredibly annoying if you're trying to save your work constantly. So I would recommend actually doing a file and going something like, I mean, you can just save this anywhere. I'll get into like hip and job folders here in a later tutorial, but let's just call this capture character.bgo, and we'll change this to write files, and then change this to read files. And now we can delete the stash and delete these guys, and now we have our captured geometry being read back into us. So this should work fine. And we'll drop down a rig pose. And one thing I'll show you now is how we can go about creating like weight painting. So from the start, this is actually probably not the best example because I kind of probably should have added some more joints to the jaw so we could rotate the right way. But yeah, it's ugly. But let's see. Let's find somewhere that has some issues. So if I start just manipulating things and finding out where I might want to weight paint stuff. So let's see. So I'll go ahead and just show you what weight painting is. Yeah, here's a good little spot for it. Okay, so Again, we use 3 iterations, which is going to, if we go back to our bone capture by Harmonic, you'll see that what it's doing is it's basically capturing areas around the our skeleton, and it's making them basically able to be manipulated by the joints themselves, or the bones. So not all of these are always the best, and one thing we'll see in this example is when we bend up the arm, we get this kind of interaction with the side of him, which we don't really want necessarily right now. I don't know, you might for whatever you're working on, but bone capture by Harmonic is pretty good, but it's not, there's going to be usually some issues. Again, for quick and dirty, usually everything's fine, but I'll go ahead and show you just how we'd kind of fix this. So we drop a capture layer paint, and what this is going to do is this is going to allow us to edit the painted weights that we have. So when I'm working like this, what I want to do is I want to change the visualize from all capture regions, which will show all of the captured weights in their own colors and stuff like that, which is why we see all these different colors. And we want to change it to selected capture region, and this is only going to show the area that we have. So when we're using this, the way we want to basically work is if we hit our right mouse button, we can we have left mouse operations, and we have middle mouse operations, and we can choose between these. So if you had named your joints or whatever, you can go through these and pick out, like if say we'd named the spine joints and then the arm joints and the leg joints, we'd have all of that information here. But since we're doing a quick and dirty rig, we don't. So an easy way to select what joints we want to work on is just the region selector. So if I have the region selector selected and I just click on the mesh, it's going to show me and move that capture region to whatever we have selected. So I can go ahead and I can go reduce, and this is going to, as long as we have this capture region selected, this is going to reduce any weighting from the area that we have selected. So I'll go ahead and do something like that. And then we likely want to smooth it, so we can either smooth layer or smooth final. Smooth layer is going to just smooth out the weights that we have selected, whereas if I go back and you don't have to switch this to all capture regions to smooth final, but just for a better understanding, it's going to smooth, if we have smooth final selected, it's going to smooth everything here. So it's going to blend it in with the top spine joint, the shoulder joint, basically everything. And the higher we increase this opacity, the more the smooth, the more effect the smooth is going to have. It is one thing I find annoying actually, is that the opacity drives the smoothness of this stuff, but it's usually way too much when we're actually painting, so you're gonna probably be hopping back and forth between these. But let's just smooth this out. Maybe smooth, and I'm just using the mouse wheel to scale up and down this guy. Alright, and so now when we move this, you'll see we're getting this effect. Now if we want to get even a little bit better overlaps and stuff, the next thing we can do is we can drop a let's see, it's called a delta mush. So this is going to work on overlaps nicely. So for example, this little overlap right here where we have the elbow bending and we have these things kind of pushing into each other, the delta mush will help out with that crease right there. So we want to plug in the deformed geometry. So we'll plug in the output from our bone to form. And then we want to plug in our reference geometry. So that would be whatever is going into this first input here. So I'll go ahead and I'll move the character rest bound null out here so we can just kind of keep everything plugged into the same thing. You'll notice immediately when I plug that in, a few things happen. So because it's taking the rest geometry, it's basically trying to find out where it should and shouldn't be colliding with itself. And we can make this more accurate by amping up the iterations. Eventually you're going to run into some issues. The step size is how far it's going to push any geometry. And so you can start to see how this can give you better looks and better deformations. So yeah, if I go ahead and I clear out this, and these values aren't what I'd necessarily be using. I mean, usually something like 0.5 and like 50 is fine. After that, you might want to just work on some weight painting or something like that. So let's dive into how we can set this rig up real quick and dirty to animate with. So the first way would obviously be how I showed you guys a while ago on the second KineFX class. There's a kind of blending layers little tutorial on how you make the tool like that, and that tool works for much more than just fingers. So like if I wanted to bend the spine, for example, let's do a rig pose real quick, and let's again with FK you can control multiple things with one controller. So if I select all of the spine joints and I rotate, each of these spine joints is rotating, and since it's forward kinematics, say this one rotates 3, or I'm rotating all of them by 3. So this one would rotate 3, and then this one would add 3 to that rotation. So now we've rotated 6 degrees, and now we've rotated 9 degrees, and now we've rotated 12 degrees. So you can see how this can create this fun, nice little smooth mix between these things. So I'm going to go ahead and clear this out. And actually, I'm going to go ahead and I'll rotate. I'll go ahead and I'll just do it in the viewport. So if I select these guys and I turn right, and then I hold Alt to copy this out, and then on this one, call this turn right, and then on this one, I'll turn left, and then turn left. And we're going to use the skeleton blend now to blend between these. So input 1, input 2, and we can blend between these. And one fun thing you'll notice is that you can actually blend above values of 1 and below values of 0. And the below values of 0 actually I think is an update in the newer versions of Houdini. So if you have 18.5, update to I think 406 or whatever it was where I first noticed that they'd updated it, because I think in the early 18.5s you can't go below 0, but you can go above 1 in all of them. So yeah, so update Houdini to a newer version, and that should work fine for you now. And I think that's real nice, just because it allows you to kind of manipulate things a bit better. So yeah, that's one quick way you can start animating in here. And then another quick way would just be quickly set up a IK chains. So let's go IK chains, and I'm going to go ahead and I'm going to create a null for this little third input. I'll call this deformed skeleton, and plug this guy in, this guy in. And what we want to do here is we want to just drop down a blast, and we want to change it to points, and we only want to select the points we want to control. So we want these drivers to, we're going to do the limbs here. So I just want the elbow, the hands, the feet, and the knees. So, and then I'll go delete non-selected. So we have these, and then I will drop an add. So the goal of this is right now they're still parented to each other. When we turn on the delete geometry but keep points, then they're just points and there's no parenting. So we don't want these drivers to be parented to each other. So then we'll drop a rig pose, and this is going to be our controllers. So if I hit the IK chains and I go root name, upper elbow, root name. Oh, no, don't want to be that guy. Yeah, sorry, I'm having some issues. Min name is going to be the twist effector. Tip name is going to be the hand, and then we can just match by name. Blend 1. If we want to orient to tip, we can check that on, and that's going to make it so that the hand rotates around the however our rotation is. So we'll keep adding these real quick. Root, mid, tip, match by name, turn it to blend to 1. Root, mid, tip, match by name, blend to 1. Root, mid, tip, match by name, blend to 1. So now we can all of a sudden very quickly just start moving around in IK. So this is an IK solver, and this is going, our elbow joint is going to control kind of our twist of the arm or the leg, and then our foot joint is going to control the goal location. And if we orient to tip, I'll just go ahead and I'll do this for all of these so you can see what's happening. So orient to tip is going to take this, if I clear this out, it's going to take this end, and as before, we were just able to move it around. Now, when we rotate this end tip, it's going to rotate the orientation of that joint. So one thing I like about this is just the control it gives you over the kind of orientation of it. One thing I don't like is how when you move this arm around now, you have to manually move the orientation of that joint with it. So I actually usually leave this off and then just orientate the hands separately if I want, unless I want, if the only reason I would not do this is if I wanted the hand to stay somewhere. So if, for example, on this hand, I think that's, yeah, it's that guy. If on this hand, it's up here and I want it to stay like this, like it's grabbing something, and I move this hand, then it's gonna stay in that same position. So, all right, so there's that. Now, if I wanted to transform stuff, so if I wanted to move him around, you can either just drop a rig pose and manipulate his hip. So the hip joint is going to be what we're moving around in world space, or whatever joint you have that's if you notice on the skeleton, everything stems from, we started with the hip and we built everything off of it, and that way the hip is at the top of the hierarchy and is the parent of everything inside of this skeleton mesh. So and that's the way most rigs are built. So if you import something, usually the hip is, or the pelvis, or whatever you want to call it, is going to be the rotator, or master kind of transform. Sorry. So call this master, and then we can drop a full body IK, which is the same kind of concept as the IK. And I'll go ahead and put these in boxes just so it's a little bit more organized. I'll delete that mask because I don't really care about it right now. So we're going to do the same kind of technique here, where we blast some nodes and then drop a add, just make sure nothing is parented. And sometimes we want things to be parented, so you don't always need that step, but most of the time we want our drivers to just be just straight up controls. So on this blast, we'll go ahead and we'll select whatever points we want. So I think I'd go something like, maybe I'll keep the hip in, the legs, and let's go the arms too. So now we have a full body IK, and what we want to do is we want to change it from mapping attribute, which is what we'd be using if we were like matching points to like motion capture or something like that, and we wanted that to affect these skeletons. I run over how that works, I think, in the 5th course of KineFX 101 that I was doing. So just change this to match by attribute, and it's going to match by the name attribute, which is what the joints are named after. And now should be able to deselect that. Just use this rig transform. Did I not? Oh yeah, I need to delete non-selected. That's my bad on this blast node, because before it was doing everything. It was giving me all of the joints except the ones that I wanted actually. So delete non-selected, and then we'll bring this in and we'll use this rig pose to now control this full body IK, which is very nice. But there's obviously some issues we can have with it. So one thing we can do is we can either pin to root, which is going to pin any unparented joints, which is nice. So we can do things basically out of the box, start manipulating a lot of this mesh. And then we can go into the full body IK and start adding and subtracting some of these weights. So when you're doing these configurations and you're adding these joints, keep in mind that adding any sort of weight to something that we don't have as a driver isn't really going to do anything. So we don't have a right knee driver. So if I put that in and then start changing any of these settings, it's not going to do anything because it's not a driver, so there's no weight that it can even kind of configure. So we need to only be using these. If I clear this out, these are joints that we have as drivers. So I'll do one for the hip, and let's see. I actually think the hip is the root at the moment. So I'll actually do a better example. I don't really want to show the hip, so let's make the right arm, and I'll put him in a position where his right arm is out there. And let's say if we increase this weight, we'll see that it starts pulling him more towards that that position. It starts basically giving that arm more influence, or that hand more influence over the rest of the body. If we lower this, you'll see even though the joint is out here, it's not affecting him nearly as much, which is something we might want to do for, like, say, the head joint. So, and you can even almost animate these if you want. I like to turn the tolerance down to 0.001, just to get any little animation bugs or anything like that, because sometimes you can have a little bit of a glitchiness if you leave it higher. It's not usually that big of a problem, but I just figured I'd mention that. All right, I think that does it for this quick and dirty rig. In the next video, I'm going to be showing you how to get solid geometry to attach to this rig. So for example, if I wanted our character to be holding something, like holding a gun or like a purse or anything really, if you wanted the rig to be able to control something, it's a little bit different than it is at the object level, so we'll go over that in the next lesson. Thank you for watching, and I will have more advanced stuff soon on my Patreon. Thanks.